Yeah? You're ready too? The thousands of people online? There are 2 people online. That's it. No, I'm just kidding. So thank you for joining. My name is Alan Jacobson. I'm the Chief Data and Analytic Officer for Alteryx. Who here has ever heard of Alteryx? 7 people. Interesting. Okay. You'll probably learn a little bit more about Alteryx, but today I'm not here really to teach you Alteryx. We're going to talk about data and analytics. For some of it, we're going to learn how to do it in our heads, and then I'll show you what it looks like using a modern tool. Of course, since I work at Alteryx, I'll probably use Alteryx to show you a modern way of doing it versus in our head, but we're going to do both. We're going to learn concepts, and then we're going to learn how to put them in practice with a modern piece of software. Does that work for everybody? Okay, we're going to cover a lot of different things today, really fast. If I am talking too fast, you'll let me know to slow down. I get very excited with data and analytics, yeah? So if you never have heard of Alteryx, we're used in every segment around the world. In public sector, we're very large, used by lots of public sector businesses. About 50% of the global 2,000 use Alteryx. So 50% of the 2,000 largest companies on the planet use Alteryx. So it's a very popular tool for data and analytics. And it's used to solve problems. Data and analytics has been around for a long time. This is a picture of a very early data scientist who was solving a problem in London. This is a map of downtown London. Does anybody recognize what this problem is about? This is very famous, sometimes taught in data science programs. So the problem in London, the year, this is about 150 years ago, 1854, it's a long time ago. And there was an outbreak, an epidemic that was happening, a pandemic that was happening, kind of timely. We just went through one of those, yes. And this person wanted to stop the outbreak. And so he was looking for where people were getting sick, where they were dying. And he took a map and he started plotting bars where people were getting ill. So this is what is called geospatial analytics. Sounds very fancy, doesn't it? Putting marks on a map. And he could tell that a lot of these marks were right around this pump where people got water. There's a well and people would pump to get water. So he said, well, why don't we take the handle off of the well and see if that solves the problem? And guess what? People stopped dying. Do you know what software he was using? It wasn't Alteryx. 1854, there was no Alteryx. Yeah. Pen and paper, right? You can do very advanced analytics without computers, right? Long time ago. Do you know what the profession, what degree this person had? What did he study in school? Any idea? Statistician? No. Mathematics? No. I'd like to think that. I'm a data scientist, so I like that. That sounds good, right? He was a domain expert. He knew about medicine. He was an OB/GYN, delivered babies. And he decided he wanted to solve this problem. He's now known as the father of epidemiology, the study of how disease spreads. That's John Snow, right? We find that people with a large amount of domain knowledge and a small amount of data science knowledge are typically the people that change the world. You have to know something about a domain and then apply the data science to the domain. So what we try to do is make data science easy so that everyone can learn how to do it. In most organizations, a very small percentage, less than 10%, know how to go past Excel, past a spreadsheet. Who here can go past Excel? Combine data together, build a model. Raise your hand if you know how to code in Python or use an analytic tool. Hopefully that's a lot of people, yeah? A lot of people. And so we want companies, organizations to have very high percentages of people that can do that. It turns out that companies that have more people that can use analytics, when they move from stage 2 to stage 3 to stage 4, higher percentages of people that can do analytics, they make more revenue, and they make more profit. So it's very important that more people can make data dance. Make sense? So what industry do you think is the most advanced for data and analytics? If you picked from these, I'll make it even better. What company do you think is the most advanced for data and analytics according to the International Institute of Analytics, which is who built that assessment? What company do you think of as being very advanced for data and analytics?
Sure.
Not industry, a company. We'll come back to industry in a second. IBM, good guess. Big company. It's a what company?
Big company.
Tech company. Yes, it is a tech company. Well, Google is a great guess. Amazon, you got it in 2 guesses. It's pretty good. Amazon scores the highest in the survey. And you mentioned the industry. Wrong way. The digital natives, the tech companies, tend to score the highest. So tech companies are the highest. Amazon, absolute highest, according to International Institute of Analytics. What industry do you think is the lowest? Healthcare. Yeah, it is. But you're good. Healthcare, absolutely the lowest. I wish it was better because one day I'm going to need healthcare, and I hope they get a lot. But who wants to help the healthcare industry get better at data and analytics? Good, good. We need people to do that. So this is a ranking by industry, and you can see some industries are much stronger than other industries using data science. All right. Now we're going to have fun. We're going to move into playing around with data. You guys want to play with data? Yeah? So I'm going to do a little bit of playing with data, and then we'll get into some non-structured data. Okay, you can see my screen. I'm going to go to my Analytic for Kids folder. You're not the kids. I have 2 kids. When they were 10 and 12, they were Alteryx certified. So this should be very easy for everyone here, because if my kids can do this, everyone here can do this. Yes? Yes? Okay. And they were trying to predict education and income, the relationship between the two. If you have higher education, you do better on standardized tests. Are you likely to make more money? That was one of the questions I asked them. We'll take a look at that in a second. I also asked them to predict who was going to win the Women's World Cup. I asked them about crime in the US, geospatial analytics. These are models that the kids built. So let's look at education and income. So the question I had for my kids is, if we know education levels in different, bring this data into Alteryx, just drag and drop it into Alteryx. So this file, I just got this off of the internet. It's a list of countries and the reading, math, and science scores on standardized tests. So the higher the score, the better. Make sense? And so the question I had for my kids is, do we think that education levels are predictive of income? And I also asked them about, if a country has more patents, do you think they make more money if they're more creative, right? More patents. If women can work in those countries, is the income in the country higher or lower? Higher, much higher, right? Having women able to work is a positive thing. And so, well, it's positive if what you care about is people making more money, right? So at least for that. So we'll just do the first one. We'll do education and income. So I'll bring income in. So I'll drag and drop income in. This is from the World Bank. And this file has a list of countries and the amount of money people make in every country, per capita income. Make sense? So we want to know if these 2 things correlate. And I heard someone say, you think they probably do correlate, yes? Because I'd be a terrible dad if they didn't correlate. I'd be teaching my kids not to study in school. That would be a bad dad, right? So they definitely correlate. So I'm going to make it harder. Do we have prizes that we can give out? You'll take down an email and we'll okay. So we'll see who can win this. Not today, but we'll follow up. Reading, math, or science, which do you think most positively correlates to income? If you want to make the most money, which subject should you study the hardest? Reading, math, or science. So everyone who thinks reading, raise your hand. So a few people. Everyone who thinks math, raise your hand. You guys are studying data and analytics, right? That's math, right? Okay. And everyone who thinks science, raise your hand. Nobody. Okay, we got one guess just to round it out, right? That's a hypothesis, right? We're doing the scientific process. We're taking a guess, and now we're going to use data and analytics to see if we're right. Make sense? Okay. So we have 1 vote for science, a lot of votes for math, and a few votes for reading. Yes? Okay. So the first thing we need to do to analyze this data is we need to, I'll use the technical name, we need to smash the two files together, because these are two separate files, right? We need to smash them together into one file, because what we want to see is a country, read, math, science, and then the income all in a row, so that then we can go do the analysis, right? What is the command to do that? Join. That would be in the data science world, that's what we would call it, right? If you live in Excel, how would you do it in Excel? VLOOKUP, right? That would be the command you would use in Excel. So at Alteryx, we try to make this easy. I can actually type VLOOKUP, and it says, no, it's not called a VLOOKUP, it's called a join. Here are examples of how to do it. It'll search some help articles that'll show me how to do it, right? So even if you don't know what a join is, this should be pretty easy. But everyone here knows what a join is, right? Yes? Okay. So if we know the word, I could just type join, it'll show it. We have these folders at the top. So we have geospatial analysis, machine learning, text mining, computer vision, and the list keeps going on and on and on and on and on and on. Alteryx has been around for over 20 years, so there are a lot of capabilities in the software. What we want to do today is join the data. And we could do fuzzy matching if it wasn't quite exact. I'll just do a straightforward join, and I'll tell it to join these two pieces of data together. Then we have to tell it what to join on. What did we want to join on? Country in one file, matching, and it guessed it correctly, the country in the other file. So I'm done. I've done the join. And I can do other things. I got these off the internet, and I want to rename the names of the columns. So I'll shorten the names from reading score, math score, science score to just read, math, science, or just rename the fields. You can do that. The income, since it read it in from a CSV file, just like Excel, if you read a number in a CSV file, it's going to think it's text. We don't want it to be text because we want to add and subtract and do math with it. So we'll change the data type from a string. We'll change it to a number. So I just changed 3 column names, changed the data type, and actually I did 3 different types of joins. So if you look at the output, there's an L, a J, and an R. And it's showing with Venn diagrams what come out each. So where the countries in the top match the countries in the bottom, they all come out the J. You can see that with the Venn diagram, yes? What's the technical name of that? And if I hover over it, it says inner join. Does that make sense? My kids don't know what an inner join is. My kids can read a Venn diagram, right? So they can use this too. This is about making it easy for everyone. Make sense? Could you do everything I just showed you in Python? Yeah? Could you do it in Excel? So far, yeah. So why would you use this? This isn't more advanced, it's the same. I'll show you other things that are more advanced, but for this, same. You'll get the same answer.
It's building blocks, not writing code. It's for business.
It's not writing code. Well, but why would a data scientist want to do it this way? I would do it this way. If you asked me to join these 2 files, I don't want to pip install pandas and like, do I really want to type all that? Which is faster? This is much faster. It's much faster, right? So if I'm going to spend all day wrangling data, this is much faster than writing Python. The other thing that I'll show you later is Python is slow. It's single-threaded. It's non-compiled language. This is lightning fast. We'll do some big data in a minute, but let's keep going with this. So I've now joined the data together. I'm ready to do some analysis. I'm going to do an associativity analysis. This particular piece is using the R programming language. You can see the R logo on the tool. When you have Alteryx, you have Python and R as part of this. And so underneath is that. And I'm going to tell it for all the numerical fields, I want to understand the correlation of everything against everything. I want to build a correlation matrix. And I'll tell it to go ahead and build the matrix. I'm going to hit run. And so now it's going out, it's grabbing the data, it's joining it together, it's linearly regressing everything against everything, figuring out the R squared, and does it correlate? And it just built me the correlation matrix. And I will now have the answer to the first question we asked, which is what's the most positively correlated thing to income. So here's the beautiful correlation matrix. We can see income, math, science, and reading against income, math, science, and reading. It explains down below how to read it, but I'll explain it for you. The darker the red the box, the more positively correlated the 2 things are to each other. So income versus reading is positively correlated. When reading scores go up, income goes up, and it's a 0.39 R squared. Does that make sense? Okay, blue would be negative correlation. Nothing here is blue, so kids, eat your vegetables and study hard at school. Yeah, matters if you want to make more money. Okay, So, and white would be scattered. No correlation, yeah? So we can see reading versus income is a 0.39, science versus income is a 0.41, and math versus income, who guessed math? Good job, we got some winners. Math versus income is a 0.44. That's the most positively correlated. But I see some really dark red boxes here. Let's look at this one, math versus science. I'll click on it, and I can see that once I know what the kid gets on the math test, I pretty much know exactly what they're going to get on the science test. I actually probably don't have to give kids so many tests. Just give them 2 tests, right? So why does the testing company make us take so many tests? I think they just want to make more money. Yeah, they hope we don't figure this out. And I know they know this because they're a customer of ours too. So they know this is true. All right, so let's build a model. I need 2 volunteers. We're going to build 2 models. Does anybody here not know how to program in R or Python or has never built a model before? Raise your hand. You've never built a model? Great. You want to build a model with me? You can stay right there. I'm gonna ask you questions and have you answer, okay? So let's pretend we want to build a model. I'll look at some data here. So down here we've got a list of countries, and we have reading, math, science scores, and we have how much money they make in those countries because we joined the data together, right? So here's all of the joined data. We want to build a model so that when our kids come home from school, we can type in their test scores, run the model, and it will predict how much money they'll make. Would that be fun? Yeah, just for fun, right? Does this sound good? Does it make sense? Okay, so I'm going to do this the hard way. We have automated modeling that just does it all for you, but we're going to hand build, well, we are. You, what's your name? Eileen?
You can say target, it's fine.
Okay, say it one more time.
Target.
Tabin.
Yes.
Okay. She was just being nice. I didn't say it perfect, but she was saying she was being nice. Okay, so we're going to build a model, or you're going to build a model that's going to predict income based on, right. So I'm going to go into our predictive tools, go predictive, and I'll just do a simple linear regression model. We'll keep this simple, linear regression model. And you only have to answer 2 questions. The first question is the target. What are we trying to predict? So which of these did we say we're trying to predict? Income. And we're trying to predict income using which predictor variables? Which is read, math, science. Good. Congratulations, you just built the linear regression model. Do we need to take a break? I mean, that was pretty hard. It's okay? Okay. So you can now build models. You can next time somebody says, who here knows how to build models? She says, yes. Anybody else not know how to build a model? I'm going to do a neural network next. Who wants to build the neural network with me? Any volunteers? You're going to build a neural network with me. Okay. So I'm going to pull down the neural network tool. Yes? We'll go there in a minute. I'll come back to that in a second, okay? So neural network. Yours is a little harder because a neural network, this list here is bigger because a linear regression could only predict numerical fields. So it only showed you the numerical fields. But a neural network, it can predict text, it can predict other things. So it's a longer list. But what did we say we were trying to predict? We're trying to predict income. Good. Using what predictors? Yeah, reading. He's got to do it. Reading, what else? Math and science. You got it. Congratulations, you just built a neural network in the R programming language. Good? You need a break or you're okay? You're okay, okay. So building models is very easy. Now I'm going to delete the neural network. I know you worked really hard on it. We can always bring it back if we need to, just to keep the screen simple. So now we're going to bring your model alive. We're going to use the model. So I'm going to bring down a scoring tool. The scoring tool gets used with any of the models. I'm going to take the output of the model, bring it into the modeling input of the scoring tool. So now this scoring tool knows if I pipe in data to the D input, if it sees 3 columns, reading, math, and science. There could be 100 columns of data, but as long as 3 of the columns are reading, math, and science, it's going to add an extra column to the end of the data set called the score, which in this case is going to be its approximation of income. Make sense? And all that happened just because I connected those 2 tools. It now knows to do that. Does that make sense? So I'll take this data that I showed you before where I have a list of all the countries, I have the test scores, and I have the actual income. I'll pipe that in, and then we'll be able to compare the predicted income, just using the test scores, to the actual income. Does that make sense? Yeah? All right. So I'm going to hit run. So now when I hit run, it's grabbing the data, joins it together. It's building the model. It's already starting to score the model. And we'll take a peek at the outcome here. I'll make this a little bit bigger for you. Bring it up. So here I see Argentina. Here are the test scores. The actual income in Argentina is about $21,000. It predicted 24, not too bad. The next country, Australia, the actual income is 48,000. It predicted 47,000. Did pretty well. Austria, great, 52 versus 48. Your linear regression is working great. Good job. But then it got one way wrong. Azerbaijan, the people are really smart. It predicted a high income, 43,000, but it's low. Any idea why Azerbaijan, it's wrong? Another factor, definitely. What do you think the other factor is? They had a thing called a war in Azerbaijan. Does a war lower the income or raise the income in a country? Lowers it, right? Does the model know anything about the war? No. So I could go out to the internet and say, show me the last time there was a war in every country in the world, bring that data in a table, join that into the data set, add that to the model, redo it, and Azerbaijan probably gets more accurate. Does that make sense? Modeling is easy, yes? Yeah? Someone asked a question about size of data. Just for fun, I will show you, and this is a reason why even if you could write this in something like Python and R, sometimes tools like this are advantageous. This is 1.5 million rows of data. So not huge. I mean, we can do billions of rows, but just for speed here, 1.5 million rows. I'm unioning it all together, and then I'm doing a finance thing where I'm seeing is the difference between two line items adding up to 0 or not. It's reconciliation kind of a process. And show me all the ones that don't reconcile. So I'm going to hit run. You ready? 1, 2, 3, run. And it is done, and it ran in 1.3 seconds. That's 1.5 million records in 1.3 seconds on my laptop. Python, you cannot do that, right? It won't run that fast, right? Now, why? Well, when you write Python code, the first thing when you hit run, it has to convert the Python code to machine language, right? It has to compile it because it's not a compiled language. We've compiled this already, so it doesn't have to do that step. That by itself might take a few seconds just to compile it, right? And we haven't even done any processing of data. If you're doing this on a cloud platform, it sometimes has to then spin up a container to run the process in. That might take more seconds to run. And then Python is usually single-threaded. It only uses one core of the computer. This little laptop has a lot of cores. But when you run Python on this laptop, it doesn't use all the cores. It only uses one. Here, I'm going to use 16 threads simultaneously. It divides up the work. It parallelizes it. And so it runs 16 times faster just because it has 16 times more resources available to it. So these are all reasons why this runs a lot faster than Python's going to run or even R, because R is typically single-threaded. Does that make sense? And this is an advantage when somebody has taken open source Python and R and really spent time to code it to be optimized. Make sense? Yeah? Does that answer some of your scaling question? So people frequently are working with billions of records in alteryx, even on a desktop or a laptop machine, very easily. It's designed for very, very large data. Much larger, certainly, than Excel. All right, so let's keep going here. Are you guys having fun? Okay. If anybody's not having fun, raise your hand, and I will try to increase the fun. Is that okay? Okay. So I'm going to skip ahead really quick. I'm going to switch now to a topic that's very popular today, which is talking about non-structured data. Is everybody here familiar with non-structured data? Do you work with it in your classes at all? A little bit? Yeah? Okay. So first, structured data, I think everyone here, I am sure, is very comfortable with. If we looked at this data and I asked everyone to sort by year or filter by category or sum the costs, no problem, right? Does anybody here have a problem doing that? None, right? That's easy. But if I asked you to take this kind of data at the bottom of the screen, and I want you to take every one of these articles and tell me if it's positive or negative what people are talking about, who's comfortable doing that? Raise your hand. Not so comfortable. It gets harder, right? It turns out it's not hard because of technology. I'm gonna show you how you can do it in your head. I'm gonna show you how a computer can do similar to what you're doing in your head. It can do it for you. I think one of the things that makes it hard is if I ask everyone to sum these costs, there's a right answer and a wrong answer, right? If I ask if this is positive or negative, you might think it's positive, you might think it's negative, right? Because language is a little fuzzy. Yeah? What's that? It's subjective to some degree. So when we ask a computer to do it, are we always going to agree with the computer? No, we don't even agree with each other. So why would we agree with the computer, right? And so I think this is one of the things that makes this hard, is the subjective nature of what some of this data contains. But we're going to talk about the methodological approach that's been used for years, decades, and then we're going to move into large language models and generative AI, some of the newest techniques that are being used to analyze data like this. Sound fun? All right. So this was one of the reviews that I had on the prior page. So here someone has made a comment about something they bought, and it says, the brightness of the lights is wonderful. They arrived late, but were a great price. Who thinks that this is positive? Who thinks this is neutral? A few people. Who thinks this is negative? It was late. Doesn't matter what else it said. It was late, right? That's terrible, isn't it? Yes? Is that why you said it? Yeah. Like some people, that matters more. Yeah, that's fair. So we didn't agree, right? But let's talk about how we came to these different conclusions. I think what all of you did in your head is you first got rid of all of the words that weren't helping us figure this out. Can you give me an example of a word that doesn't help us figure out if this is positive or negative? Tell me a word that you can get rid of. Which one? The. Price? Yeah, probably. Bright. Who likes lights that are bright? I like lights that are bright. I mean, that could be positive or negative, right? It could be ambiguous, but bright could be what somebody decided mattered. But the word the, I think we can all agree, the is not doing anything, right? Can you name another word? There you go. So we can take out what are called stop words and remove them. So we get rid of all the stop words. That's step one, right? Now the second step is we take these words that might have meaning, and we usually stem them or lemmatize them. We take them down to the base. So if I say run, ran, running, runs, it's all the same, right? Right. We don't need to have all these different versions of the word. So normally we would take all of these words down to the base, something like this. Now I missed one word. Actually, here I missed two words. I missed two words. Bright, so brightness should be bright. And what's another one I missed? No, wonderful. What should wonderful be? Wonder. Wonder, right? Wonderful should be wonder. Brightness should be bright, right? But this is called stemming or lemmatizing, right? And then believe it or not, people went through the entire dictionary, and they've done this in many languages, and they took all of these base words, and someone decided, this one's positive, this one's negative, this one's really positive, this one's really, and they put point values for every word in the dictionary. Who wants that job? It's a terrible job. Now, do you think if I had you go through the dictionary and assign points to all the words, positive and negative, and I had you do it, do you think you would agree? No, so there actually are multiple libraries that exist in the data science world that have point values that different people have built, and they don't all agree with each other. But I could use one of the libraries called Vader and use Vader's definitions. It's going to assign point values, and then Vader would look at this and say, we think this is 0.89 positive. And it's on a scale of +4 to -4. So we think it's somewhat positive. Does that make sense? And this is a very old method. It's called a lexicon method for doing sentiment analysis. So we just did some text pre-processing, some lemmatization, some stemming, and then some sentiment analysis to figure out, is it positive or is it negative? Does it make sense? Is it hard? Conceptually very easy, yes? Okay, so there are these lexicon-based approaches. I just showed you Vader, but there are other libraries that exist in the world. They're going to give you a different answer because people put different point values. I could have done the same approach with machine learning, but with machine learning, I would have needed thousands, maybe even hundreds of thousands of reviews, and they'd have to have point values of are they positive or negative, and then I'd train a model to figure out basically all the point values, and I'd build my own model. Most people don't do it that way because you need a lot of training data, all tagged, in order to do that. But that's another method, is a machine learning method. But these are the two most common, I'll say, older methods that have been around for a long time to process data. Now, there are problems when you do this, and you mentioned some. If I asked you on this first statement, does that sound positive or negative, what would you say? The pump has an awesome battery backup of 2 hours. Could be negative, could be positive. If I told you this was talking about in Dubai, someone had a pump so that when there's a flood, it could pump the water out, and it's good for 2 hours. Sounds pretty bad, doesn't it? Sounds terrible based on what just happened, right? If I'm talking about it's a backup for my phone for 2 hours, maybe that sounds pretty good, right? 2 hour backup for my phone, that sounds great, right? So it depends, but you can't tell reading the sentence, right? So that's ambiguous. So if you score that, is it going to get it right? Maybe, maybe not. Like, we can't get it right. We're not sure. The story is unpredictable. Who thinks that's positive? Who likes unpredictable stories? Some people like unpredictable stories. Who thinks that's negative? Right? I mean, it could be either. It just depends on what you like, right? So these methods can unfortunately get wrong answers because of sarcasm, ambiguity, or compounding. In the first example I showed, it was compound. It had positive things and negative things. Which one counts more? It depends on the person, right? So it can be very hard. So these things that we just showed you for sentiment analysis, normally scored on a scale of -4 to +4. You usually decide what you're going to call neutral. So these are tunable. You decide. But the same thing can be done with emotion. So when you're chatting with a chatbot for a company and you say, you know, I need help fixing my computer, and you start yelling at the chatbot. Does anybody yell at the chatbot, you know, when you're typing, right? You get upset at it. The chatbot might actually be detecting your emotion. It might decide, oh, it looks like you're really angry. I better escalate this and have a human intercede. And you can programmatically do it. So the very same method that we just used to decide positive and negative sentiment, people have gone through the whole dictionary and scored words for how angry does it sound, how disgusting, how sad, how surprised, how fearful. People have created the same technique for emotions. And when you combine two emotions, if you're angry and you anticipate something, you're aggressive. If you're angry and surprised, you're outraged. And you can do the intersection of any two emotions, and that creates a new emotion. So the basic scoring only has to score these yellow ones, and then through the combination, it can figure out almost every emotion. It's pretty interesting, yeah? So you can use the same techniques to do emotional detection. Now, how do companies use these things? This was an example I did for Coca-Cola. You're all familiar with Coca-Cola. Coca-Cola was early on their journey. This was just a few years, I think, 2019, so a few years ago. And they asked, hey, we're really interested in using sentiment analysis. Can you give us an example of a use case? So just for fun, I said, well, I'll go to Twitter, now called X, right? I'll go out on Twitter and I'll look for what everyone is saying about Coke. And we'll monitor how positive and negative their statements are. And we could see that suddenly there was a huge spike right when I ran the analysis. There's a huge spike of negative sentiment. People got really upset. So we went out and looked at what topics are they talking about. And that's here. And they were talking about plastic bottles, and people don't want to keep reusing plastic bottles. What happened was a vice president at Coca-Cola on Twitter posted that they don't plan on getting rid of plastic bottles because people like plastic. And they're the head of sustainability. And a bunch of environmental people responded, that is a terrible answer. You need to be eliminating plastic. It's not great for the environment. And that's why that spiked up. By monitoring it, they could see that that happened and then address it, respond to it. Make sense? Really easy to build a workflow to do something like that. So there are lots of ways that you can use natural language processing, whether you're in a contact center, human resources, IT, legal, marketing. There are hundreds of use cases. But now I'm going to switch, and we're going to talk about how you would do this with a large language model. Does that sound like fun? So I took the review that we just talked about, and I typed it in to ChatGPT just for fun, right? So this is that same review. The brightness of the lights is wonderful. They arrived late, and I said, tell me the sentiment analysis. And you can see it did pretty much what we were doing. It said, hey, there were some key words despite mentioning late, so it knew that was negative. I also saw brightness, so it did use the word bright to say that seems good. Affordability, the price was good, right? So it used these same keywords. It scored it, and it came up with a slightly different score. It said 0.6 to 0.7. Vader, if you remember, was 0.889. So slightly different score, but pretty similar. Yeah? Still positive, slightly different, but directionally very similar, right? So let's talk about how LLMs work. So this is participatory. You're going to fill in the blank. I'm going to read the sentence. When I get to the blank, everyone shout the word. Now, I know this is in English, not Arabic, makes it a little harder, but let's see how we do. Roses are red, violets are blue. Everyone agreed. Good, okay. How are you today doing? I heard 2 answers. Okay, good. What is it? I heard time, and I think someone said day, yeah? But it's good. Congratulations, you are all LLMs. You guys are pretty good LLMs. Now, how did you do that? Like when I said roses are red, violets are blue, did you think about what does that mean? What is it about? No, I mean, you've just seen the pattern of the words before, and your brain said, I've seen this pattern. The next word is most likely this word, right? It wasn't about what does it mean or anything like that. It was just what's the most likely next word. Now, with LLMs, there's actually a dial for how creative you want the LLM to be. So if I said, look, I want you to give me a really creative answer. Don't give me the most common thing that comes next. Come up with something that someone might say, but not the most common. And I said, how are you blank? You might come up with a different answer. Does that make sense? That's not a hallucination. This is a tuning knob on an LLM of how creative. If I want a LLM to write me a beautiful song, but I don't want it to exactly copy an existing song, I need the creativity to go up a little bit, right? Because I don't want it to be an exact copy of what someone else did. Does that make sense? So depending on the use case, we dial what's called the temperature, and the temperature is that creativity knob for almost all the LLMs that are out on the market. So what you just did is how LLMs work. And the way we train LLMs is we give LLMs the same thing we gave you. The way you were able to go roses are red, violets are blank is because we gave you lots of things to read and hear, right? That's what we trained the LLM on. So we give the LLM lots of data, lots of stories and books and things on the web, and we blank out one word, and then we try to get it to fill in the word. And then we blank out 2 words, try to get it to fill in the 2 words, 3 words, until basically I can ask a question and it can fill an answer in. Does that make sense so far? Yeah? Okay. Now, the construction of this is that there are foundational models. There are many, there are hundreds of them already. These are some popular ones like OpenAI, Google, which I tended to use a lot in this presentation, Anthropic, Meta, Stanford has a great one called Alpaca. But there are tons of these. There are lots of foundational models, they're called. And once you have a foundational model, typically to solve a real problem, you then need to add domain-specific information to your model. And we do that through what's called retrieval augmented generation, or RAG. Have you guys heard of RAG before? Yeah? So if I'm a car company and I want to have a model so that any of you can chat and ask a question about the new model vehicle I just launched. So you could ask a question like, how do I open the trunk? And I want to create a little chat bot so that you could do that. I would get one of these foundational models. And if I just let you type in, how do I open the trunk of this brand new model that I just launched, what's the model probably going to say? Yeah, it'll probably use it probably won't say I don't know. It'll probably use the previous. So if I ask you, how do you think I open the trunk of my car? Tell me how I would do it. I'm really stuck. I need it. How do I open it? No. How do I open it? I need right now. Tell me how to open it. I'm your kid. I'm stuck on the highway. I need to open the trunk. No, yeah, give me an answer. Yeah, how? I'm a kid. I have no idea. Tell me how to do it. How do you open a trunk of a car? Do what? There should be a pull somewhere. Where? Tell me where you would look. Yeah, it might say, hey, look under the rear seat, look for a pull handle and pull it. Okay, there's not one there. What's another guess? No, it doesn't. In the back, go look in go look in the center console for a button, right? It's going to use the most popular answers. It's like roses are red, violets are blank. You guess, blue, right? Good. Open trunk, you say, look for a handle here. If you don't see it here, look in the center console for a button. If you don't see it there, right, that's what it's going to do. Does that make sense? And depending on the temperature, is how creative that answer is going to be, right? But it's going to do exactly what you just did, right? But that's not going to be good enough for our car company, right? We want it to give the right answer. So the way we do that is with RAG. So you could do that with, let's say, OpenAI. You could go to OpenAI, you could say, here's the actual owner's manual for the vehicle, feed it in, and then ask your question. For this owner's manual, how do I open the trunk? But you don't want to make your customer have to feed in the entire owner's manual in order to ask the question. That would be very bad experience, right? So what we do is ahead of time, we take the foundational model, we take the owner's manual, we tune the model in with RAG with the owner's manual and say, I want you to use this context. So when people ask questions, your answers need to use the context of this owner's manual. And that's how we use RAG. Does that make sense? So this is a very important technique pretty much for almost every use case, many use cases, that you have to know how to add domain-specific information to the model.
But would the original model have the information that I have been feeding?
It may or may not. So if it's a brand new model that I just launched today, was that in the training set of the model? Couldn't be. So I have to add it.
But after like a training or
It depends on the model. For some models, that might be a year from now it's in the training data. It's not going to be instantaneous. What's that?
I have a case like this. I want to train for the specific case, but I want the original model to have this data about like my company.
Correct. So normally if you want to have it answer in the context of a specific thing, you're going to use RAG to do that. Whether you put that information in the prompt, one way to do it, or you pre-give it and create basically a new model that's the combination of the foundational model plus the RAG is the new model, and then it does that from that point forward.
Can we prevent the user from using specific data from the foundational model? Like, for example, I think there's a use case about food delivery company. They used a chatbot, and one of the users asked them which company is the best in the delivery.
And it gave the competition's name.
Yep.
Yeah. So, and by the way, do I need to repeat the question for the people online, or they can hear? Any idea? I don't. Okay. So the question that you're asking is, can you get the chatbot to not do certain things? I won't even say leave out data, but really not do certain things. And you can. The way that most people are doing that today is actually not in the model. They have the person ask the question, the chatbot gives the answer, but then they run checks on the answer. They say, okay, this answer, is it angry? I don't want you to be saying angry things to my customer. If it's angry, try again and be nicer. If it has profanity, try again, no profanity. If it is sexually explicit, not allowed, right? And so you could actually put a rule that says, if somebody asks you which company is the best, or I don't want you to ever mention the competition's name no matter what, you can check the answer, and if the answer comes back a way you don't want, you force it to try again. And when it tries again, what's the knob you use to get it to give a different answer? Temperature, right? The creativity knob. And you try to get it to try again. So the most common method for doing that people use today is by putting checks in. I think over time, people will figure out better ways of getting that into the base model itself, but most people are doing it with checks.
How about architecture for the specific domains? Like you want to go to a specific domain, that domain, general websites, general paper, but also there's a journals, scientific journals, or credited or like copyrighted materials that cannot be released by the domain owners. So how is that can help in terms of building?
So we'll talk about issues like copyright issues that are starting to come up with these models. I'll cover that in a little bit. I mean, obviously, if it's against the law to do something, you shouldn't be doing it. So I'm not sure. I mean, there's not a way to put illegal things into your model. You just shouldn't put illegal things into the model. Yeah.
Decision or a conclusion or a recommendation that based on references. Most of the references are unfortunately is not.
Yeah, I mean, it depends. There are a lot of, in the medical community, most of the literature is open source. In other words, anybody can read medical papers and learn from medical papers and use them. So it depends, but again, you'd have to check in the country that you're in what the laws are and what you're allowed to do and what you're not allowed to do relative to what goes in the model. So I want to give you a little perspective about the size of these models. Now, I wrote these slides, I want to say like 6 months ago. So these are already out of date, but I'll reference kind of what generation I'm talking about here. So this is in the day of ChatGPT 3.5. We're already at 4 going on to 5 now. So this is at 3.5. The largest LLMs at that point in time contained about 20 terabytes of data in the model, and that's after it's been compressed. So the 20 terabytes is probably roughly about 400 terabytes of total data that got compressed down to about 20 terabytes of data. Now, many people would say that's almost all the text on the public internet. That is a lot of data, right? 20 terabytes is a huge amount, and I'm only talking text. I'm not talking about images. And LLMs are starting to do images as well, and we're going to talk about that in a minute. But this is just text. So 20 terabytes, that sounds like a lot, yes? Yeah, everybody agree, that's a lot of data. But I want to put this in perspective. I'll come back to that. A human, when they're 4 years old, a human has taken in a petabyte of data just through their eyes. So if you have a 4-year-old kid, they've taken in a petabyte through their eyes. Now, how do we know this? Your optic nerve takes in about 20 megabytes per second. And I know how long you're awake 7 days a week till you're 4 years old. I can calculate roughly the petabyte of data. So just to give you a perspective, 20 terabytes is actually kind of tiny compared to just what a human has taken in through their eyes. So if you feel like LLMs sometimes act like toddlers, you're probably right. Right? They only have the information of a toddler. Now that's changing. We're starting to put more data into LLMs using pictures and audio and other signal than just text. We're starting to put more in, but we've almost run out of text to put into the models. Now, I want to talk a little bit about some things that are happening with these models already at this generation. And again, the models are getting better. But one of the experiments that was done is they took the LLMs at this point in time. They had about 40 languages that they had fed into the LLM. And they asked the LLM to translate a new language that it had not seen before. And it actually did it pretty well. Anybody surprised by that? The researchers were pretty surprised by that. But if you think about it, if I told you that he speaks 5 Romance languages, and I asked him to translate a 6th, do you think he could do it? It'd be pretty good, right? So the researcher said, now we're going to make the test harder. I have these 2 whales that are talking to each other, and I'm going to ask the LLM to translate what one whale said to the other. And the LLM did. It translated it. And the LLM said the whale on the left said, I love you and I want to marry you. Did it get it right? Believe it or not, there are at top universities researchers out in the ocean right now, behavioral scientists, trying to determine if the LLM got it right or not. I'm serious. This is real research. Why would it get it right? Give me a reason that it could get it right. What's that? If whale's language is similar to human language, there's a chance it could get it right. Why would it get it wrong? If whale language is not similar to human language, it's going to be completely wrong. Yes? Can we know? Well, yes. If you go out into the ocean and you think, this whale said, "I love you, will you marry me?" and they stayed together, had babies, and lived together forever, you'd say, yeah, maybe it got it right. If they got into a fight and went in opposite, you'd say, maybe it got it wrong, right? And so there are ways to determine if your model is performing the way you expect it to or not. Now with LLMs, you have to do checks. You can't just assume the answer is right because you asked the question and they gave you an answer, therefore it's right. You have to do checks. That make sense? But it is possible to check, even things like this. And this is real. This is actually going on. Interesting? Yeah? So the same approach that I just showed you being used for text. Everything we talked about, I feed in a bunch of text, I cover up one word, I try to get it to predict the word, I cover up a different word, tries to predict the word, right? 2 words, 3 words. The same thing's being done with images. Now, historically, even language models have been out for a long time. They're not new. They've been out for over a decade. And language models have been used for image processing for years. With images, people are typically using mixed techniques. They're using LLMs, but they're also using other techniques when they do image processing sorts of things. But here the approach is similar. We take a picture, we cover up, like a word, we cover up an area of the picture, and we ask the LLM to fill in the blank. And we keep doing that until eventually the LLM can do the full picture. Now, by the way, in this presentation, all of the images, of course, were generated with generative AI. I'm using Google Image FX for this one, but throughout the presentation, I've been showing you images. Who here, when you make a PowerPoint presentation, goes into Google and types in, show me a picture of a bird, and then they, copy and paste the picture? You all do that, right? So who here has used something like Google Image FX? Have you used it before? A couple? So the way this works is you type in a prompt. You say, give me a picture of a bird flying, and I'd like the bird to be blue. And instead of it copying a picture that already exists, it generates an all-new picture of a bird that's the combination of lots of other pictures that it's seen historically. Does that make sense? So all of these are generative AI pictures that I'm showing on the screen. And it's using this technique of kind of covering up pictures. So I'll give you an example of how companies might use this technology. And this is a pretty safe way to do it. Imagine you're on a vacation, you take a picture of yourself on the vacation, and you want a business appropriate picture to put on the internet. And so here it takes the picture of the person and it converts it to the same person. It changed their hair, changed what they're wearing, changed the background to make it business appropriate. Yeah? Does anybody see anything wrong with that? If I'm in this country, is that business appropriate? Doesn't look like how any of you are dressed, right? And this is a problem, is the training data that's been largely fed into these models have been, Western European, North American images, techniques, and so it has a bias in it. It's going to show this business appropriate according to the Western world, but that doesn't mean that that's right. That's the right way to do it. The other way that you got it wrong, this is from about a year ago. This is a different company than this one, but about a year ago, this is a company doing the same thing, taking an image and creating a business appropriate image with it. Does anyone see anything wrong with this picture? What's wrong? 1, 2, 3 hands, huh? Remember, the LLM doesn't actually know things like how many hands people have. That's not how it's doing what it's doing. So it can make that kind of a mistake. That's a hallucination, right? That's something we don't want. Now, clearly they've gotten better over time. Does anybody see anything wrong with this picture? Anything else wrong? Eyes don't look right, but you don't know what her eyes normally look like, and that's actually pretty close. Fingers. What's wrong with the fingers? Yeah, this is a very common early problem. 1, 2, 3, 4, 5, 6 fingers. Think about why it's doing this. If I show you 2 pictures and I ask what's likely the next thing you see, what's the typical next thing you see? Another finger. It got a little carried away, right? It kept going, right? And so in the early versions, you could have 6 and 7 and 8 fingers because it was using this technique of filling in the blank, and you can imagine why it would do that. Now, interestingly enough, if you asked a 5-year-old kid to draw somebody's hand, would they put 9 fingers? No. So they understand the world in a very different way than these models do. So some people are confusing what these models are doing with human cognition, This is not human cognition. This is a statistical model, right? Looking at most likely next thing that's there, but there's a very big difference between the way a human processes this and the way that, the LLM is doing what it's doing. Does that make sense? Yeah? You guys still having fun? Okay. Now, things can go wrong with LLMs. So I'll give you an example of something that goes wrong. We're the IT department here. They asked you to build a chat bot to help people when they have problems with the computer. Someone says, my computer is broken to the chatbot, and the chatbot goes, that's because you're an idiot. Bad chatbot. That can be a problem, right? People can get very offended, very upset, and there's a responsibility not to let that happen, right? What would we do to you if you said that to somebody? Fired, right? What do we do to the chatbot? We can't fire the chatbot, but we can still fire the person who made the chatbot, right? So what's the responsibility of the person, the data scientist who's actually doing this behind the scenes? And so there are big responsibilities, even if it's not going to be external. Now, we talked about this one a little bit. Here I'm actually showing the interface of Google FX. So I typed, show a successful chief financial officer. What do you guys see wrong with this picture? What's that? What's biased about the pictures? Yeah, clearly they're dressed like Western European again. I would even say if you're Western European, you still don't like that picture. So it gave me 3 options. It says pick one of these 3. This is one of them, but pick one of the 3. They're all white men. I didn't notice they're all wearing glasses. Like, is this real? Now, statistically, is this probably true that many CFOs look like that? Yes. But is that what we want the answer to be? Maybe our daughter is doing the search and wants to know what a chief financial, and they go, okay, not me. I can't be a chief financial officer because they look like that and I don't look like that. We don't want that to be the answer, right? But who gets to decide? So even if we broaden the training set, so we have African CFOs, we have Asian CFOs, and we get ethnicity, right? If it's still doing what statistically exists today, they might still all be men, because statistically, most of them are men today. But is that what we want the answer to be? So Google actually, it's funny, I gave this presentation for the first time, it was probably 3 or 4 months ago, and when I gave the presentation was the day Google ImageFX shut the image generation of people off. They've turned it back on, but they shut it off because of this problem. And it wasn't because of this, they actually put in a fix for this. They dialed up the diversity. They made it give diverse answers. But then people typed in things like, show me a German World War II soldier. And it showed Asian women and black men, and like, that's offensive too. Like, that's not what they look like, and that's inappropriate, right? And so the problem is dialing this to be right. It's very subjective. What I think is right and what you think are right might be 2 different answers. So it's very ethically and morally difficult to figure out the right answer. So this makes this space very different than structured data. 2 + 2 = 4. No one's offended. That's easy. This, very hard for many use cases. So the key is picking use cases where this isn't going to get you in trouble. Right? Does that make sense? And I'll give you an example of one here in a minute. You asked about copywriting and what's in the training set. Actually, he asked the question, but he left when I went to go answer it. So he'll never find out the answer. Somebody will tell him the answer. So this is probably the biggest legal challenge that's going on right now. Most LLMs have put a ton of data into the LLM. Most of the LLMs don't want to tell us, the data scientists who are using them, what's in it. Why do they not want to tell us what's in it? Because people are suing them saying, I didn't give you permission to use my data, and if you want to use it, I want money, right? It's always about money. And so there are legal cases. The most famous one is the New York Times. So here I asked Google ImageFX, give me a picture of someone reading the New York Times. Does that look like the real New York Times logo? Do you think the LLM knows what the real New York Times logo looks like? Of course it does. So they probably put some checks in that said, hey, whenever you're going to use an image, I need your creativity to go way up. I don't want it to look like the real logos because I don't want to get sued, right? Now, how did the New York Times figure out that the OpenAI LLM had New York Times data in it? How did they know it's in it? They didn't ask because the model doesn't, it has rules that when anybody asks, it doesn't want to give the answer of where the data, so it prevents it from saying that. But they did a different trick. So what they did is they took an article from the New York Times, word by word, and I give it 500 words of the article, and I say, what comes next? Right? And if it knows the rest of the article, then we know it had that in the training set, right? And that's how they figured out, that's how the New York Times figured out, you're using our data, I am suing you. Not because they asked and the model said, of course, I'm using the New York Times. They use these techniques to basically reverse engineer and figure out that it was in the model. So these are huge legal battles. And the problem is if you're using OpenAI and they lose this, then potentially you have liability because you were using the copyrighted data that they were using. Now, what OpenAI tries to do is they say, if you do business with us, we'll protect you from the liability. If someone sues you, we'll defend you, right? Until they're out of business, and then you're going to have to find a different model. Time? I have to stop? I don't want to stop. I still have 2 minutes? All right, so I'll finish with one last thing. I'm going to finish with a demo again, just to show you how easy it is to do generative AI and structured data using tools like this. So I took the review here. The brightness of the lights is wonderful. They arrived late, but were a great price. And I'm going to use drag and drop ways to do what we just learned. Text pre-process the data. Tell it, this is English. I want to take that text and, oh, you can't see anything I'm doing. Hold on. Boom, almost there. Come on. What was that? Share screen. Okay, hold on. Unplug and plug in when everything else fails. Isn't that the technical solution to everything? Unplug and replug in? Always what you do. I'm going to close these. Hey, look at that. Okay, so let me try that again. Delete this. Come back here. See, I need the 5 minutes that we started late at the back end. The brightness of the lights is wonderful. They arrived late, but were a great price. I'm going to first pre-process the data. So we'll do text pre-processing. I'm going to tell it English, take the text, convert the words to their root, take out the stop words. That's what we did when we did it in our heads, right? Now I want sentiment analysis. Here's sentiment analysis. It's going to use English, Vader, take the process data, do Vader, done. If I hit run, it's going to say 0.889, that's the score. It's that easy, right? So what we learned to do in our heads, that easy to do here. The last example I'll show you is generative AI. This is an example where I took a list of companies, Apple, Goldman Sachs, Raymond James. These are the ticker symbols for these companies. I want you to pretend you're an investment bank kind of a company. You give your money to me. I invest it for you for retirement. If there's a problem with one of the companies we're invested in, I need to call you and say, hey, Apple's having a big problem. They just got sued. You want to sell your stock, right? And so I need to keep up with all of these companies. So I wrote a prompt here that says, for each one of the ticker symbols, you're a helpful industry analyst. Your task is to look at public events that may impact the company's performance for each one of those ticker symbols that were in the other file, right? And so I run that prompt. And when I run this, I'll just show you the results. It says here for Apple, they launched a phone and had increased revenue. Maybe you want to buy more stock. They announced a partnership with Samsung, buy more stock. Down at the bottom, increased scrutiny, potential fines, legal issue. Maybe it's time to sell the stock, right? Does that make sense? So that would be a good use of an LLM. Now here, I'm not worried about privacy. When I send the data out to Google, or in this case, Gemini, to run the LLM, I'm just sending it a list of companies. So I'm not giving away anything secretive. I can then check, show me the sites where you got this information from. Did you hallucinate? Show me the reference so that I can click on those and check, do I agree? Do I disagree? Did you make it up? Did you not make it up? And with that, I will end because it was way too late. I could go for 5 more hours. Do you guys want to stay for another few hours? No, I'm kidding. Did you have fun? Is this fun? Did you learn anything? Little? Yeah? So thank you very much. If any of you are interested in alteryx, because I demoed most of this with alteryx, give him your email, write down your email, provide it to Noir, and we can get you free licenses for education purposes. Alteryx is free. So it's not very expensive, right? It's not very expensive. Very, very affordable. Can you guys afford free here? Is that a good price? Okay. So let Noir know if you want to learn more. We have online training. You can get certified online. And how much does that cost? Free, of course, for education. Does anybody here work for a company? So for those of you who work for companies, not free. Not free. But he can also help you out with trial licenses and teach you how it works with trial licenses for free as well. Does that work? I'm not a salesperson, so everything I like doing is how much? Free. Free. Okay. Thank you very much.